Welcome back to our algebra final exam review. For today, day 13, we're going to begin our statistical review. Make sure that you need to have your calculator handy. All right, and today we're going to be taking a look at statistical vocabulary, two-way frequency charts, scatter plots, correlation coefficients, residuals, and your line or curve of best fit. So we're covering a lot of information today. So let's jump right into it. All right, we're going to start with some vocabulary. So let's take a look at number one. In the 2015 playoffs, LeBron James scored, and here's a list of all of his scores. Given these totals, we want to find, all right, so here's all of our statistical vocabulary. Now, to find most of these terms, I'm going to let the calculator do the work. So I'm going to go ahead and hit the Stat button. I'm going to go to Edit. And in L1, I'm going to input all of my scores. Remember, every time you put in a score, you then have to hit the Enter button, okay, especially after that last one. Okay, next up, we're going to hit Stat. We're going to go over to Calculate. Now we have one list, so this is one variable statistic. So I hit 1, and I go down to Calculate. And here we have a lot of information, so let's double check to see what we're going to need. So the first term that we want to find is the mean. Now the mean is the mathematical average, and the symbol for that is X bar above it. So our average is 27.5. Our median is the middle number when all of these are written in order. Now if I use my down arrow, I'll see there's even more information, and there we have the median, which is 27. All right, now the mode button, it's not in the calculator. We have to look carefully at our scores. The mode is the one that is the most often. So let's take a look to see if any of our scores occur more than once. 25, 25, 27, 27. So we have two modes here. It'll be 25 and 27. Okay, next is the range. Now the range is how spread out the data is. So range is going to be your spread. Now to find the spread, we're going to take the max minus the min. Now our maximum value here was 38. Our minimum value was 19. So if we subtract those, we get a range of 19. Okay, next we have quartile 1. Now quartile 1 is your 25th percentile. So that means all 25% of your scores are at or below this number, and Q1 is 25. Q3, so your third quartile, think 3/4, that's 75 percentile. So 75% of your scores are at or below 31. Okay, the next one, your IQR, that's your Q3 minus your Q1. So if we plug those in, we get 31 minus 25, which gives us 6. Okay, so your IQR is 6. This is the middle 50% of the data. Has a spread of 6. All right, so this is our statistical vocabulary, so we can check that off. So next, we're going to take a look at a two-way frequency table. So here's our two-way frequency table. So we have a school newspaper survey the student body for an article about club membership. The table below shows the number of students in each grade level who belong to one or more of the clubs. If there are 180 students in 9th grade, what percentage of the 9th grade students belong to more than one club? Okay, so here we're taking a look at the 9th grade students. So we're not looking at 10, we're not looking at 11, we're not looking at 12. And I want the students that belong to more than one club. So that's going to be 2 clubs or 3 or more clubs. Now remember, a percentage is part over whole. Now they told us the whole is 180 total students. Now the part that are in more than one club, that's 33 plus 12. So the first thing that we have to do is add those together. 33 plus 12, and we get 45. Our total is still 180, so then I divide that by 180. I get 0.25. But remember, for a percentage, you have to move it over twice, so 25% is our solution there. All right, and that's a review of your two-way frequency tables. All right, let's take a look at question 3. So here we're going to take a look at a box plot. So remember, it's box because, well, you have a bunch of boxes there. And this is where you have your minimum, your Q1, your median, your Q3, and your maximum. So if we take a look here, we have Corinne is planning a beach vacation in July and is analyzing the daily temperatures for her potential destination. She would like to choose a destination with a high median temperature and a small interquartile range. She constructed box plots to show the diagram below. All right, so let's take a look. So which destination has a median temperature above 80? So a median above 80 degrees. And the smallest interquartile range. So the interquartile range is going to be that box. Okay, well first, let's take a look for the median. A median above 80. So if I go to 80, I want my median, which is the middle line, to be above 80. So here's 80. Okay, so Ocean Beach is not above 80. Whispering Palms, yep, it's above 80. So here's 80. Serene Shores is not above 80, but Pelican Beach is above 80. So now which one of these two has the smallest interquartile range? So the interquartile range, remember, is the box part. Well, that would be Pelican Beach. So that's going to be choice 4. All right, let's flip it over. All right, next we're going to take a look at correlation coefficient in our scatter plots. So what is the correlation coefficient of the linear fit of the data shown below to the nearest hundredth? So remember, correlation coefficient, this is going to tell you the strength of a linear relationship between the data. So if I take a look here at this scatter plot, I can see that there seems to be a relationship, and it looks like my data is going in a downward pattern. So it looks like I'm going to have a negative relationship here. So that means I'm going to have a negative linear relationship. Now, if the points are close to the line, that means your number is going to be close to 1 or -1. If they're spread out, that means your R value is going to be close to 0. So if I look here, my points are all pretty close to the line, but they're not all on the line. So it can't be a perfect 1. A perfect 1 is when all the points are on the line. So it can't be 1. Because it's negative, that means we want to make sure that it's a negative value, so we cross off 2. Now, a -1 means all the points are on the line, in which case this is not, so our answer here would be 3. All right, next up, number 5. So here in number 5, it says the table of value below represents the residuals for a line of best fit. Remember, your residuals are the distance from point to line of best fit. Okay, so if we take a look here, these points, so this one's below the line of best fit, this one's above the line of best fit. So those would be your residual, would be how far away from the line of best fit it really is. So if we take a look here, we have our x's and we have our residuals. Remember here, your x, this is actually your line of best fit. So we're going to go ahead and we're going to plot. So we have 2, 2. So over 2, up 2. There's our first point. 3, 1, 2, 3, up 1. 3, -1. 4, -2. 6, -3. 7, -2. 8, -1. 9, 2. 9, 0. And 10, 3. So plot the residuals, we just did that. Now it says, what does the residual plot tell you about the data? Well, does this data show that a line would be a good fit? Okay, so we would say no. So line is not a good fit because the data, or we shouldn't say data, let's actually use the word residuals because that's the word they gave us. The residuals follow a pattern. pattern. All right, we want our residuals to be scattered above and below our line of best fit. Here, it follows a pattern. So a line is not a good fit. All right, let's flip it on over and let's take a look at our last question for today, number 6. A nutritionist collected information about different brands of beef hot dogs. She made the table showing the number of calories and the amount of sodium in each hot dog. Write the correlation coefficient for the line of best fit. Round your answers to the nearest hundredth. Explain what the correlation coefficient suggests in the context of this problem. All right, so here we want to use the correlation coefficient. So that's going to be your R value. Now we have to do something a little bit unique in our calculators right now. So in order to get the correlation coefficient, you need to turn your diagnostics on. So in the calculator, we're going to hit second 0, which is the catalog. Oops. Okay, and we want to go to the word diagnostic on. So right now we're in alpha, so we're going to go down to the D's, and we're going to go down till we see the word diagnostic on. So just use your arrows. Diagnostic on. I hit enter. Now I have to hit enter again, so that way it says done. Okay, now I'm good to go. All right, so what we need to do to find the correlation coefficient, we have to put our table of values into the calculator. So I'm going to go stat edit to clear out my list, and then I'm going to go and put in all my values. All right, so here we go. I have all of my values in the calculator. So now I'm going to hit the stat button again. I'm going to go over to calculate. This time, I'm going to go to the word linear regression, which is option 4. And I'm going to go down to calculate. And I'm going to get all of this information. So this information is telling me the line of best fit, that goes with the A and the B, but it's also telling me my R value. Now my R value is the correlation coefficient. So here they want me to round to the nearest hundredth, so that's 2 decimals, so it would be 0.94. So this is my correlation coefficient. And that's what they're asking me for. Now, if you'd also like to write down your line of best fit, you can, but it's not necessary here. So our line of best fit here would be y equals 4.59x minus 346.60. All right. All right, so next, part B. Explain what the correlation coefficient suggests in the context of this problem. So 0.94, is that a strong relationship, a moderate relationship, or a weak relationship? So here, this would be a strong. Now, our R value is positive, so that means it's a positive. We just did a line. This is a line of best fit, so it would be linear relationship. Okay, so that's the relationship. So now we have to know, what does it suggest about the context of this problem? So let's go read it. Calories per beef hot dog in milligrams of sodium. So if it's a strong positive linear relationship, that means, okay, the more calories, then the more sodium the hot dog will have. All right, ladies and gentlemen, statistics was a very big unit for us during the school year. We've just reviewed quite a bit of information: statistical vocabulary, charts, scatter plots, correlation, residuals, and our line of best fit. All right, tomorrow in class, we'll be practicing all of these. Have a great night.